Namaste and welcome back to the DSA Problem series. Here I am discuss about the maximum sub-array problem, lead code 53. What is tell about this? Given an integer nums, finding the sub-array which is largest sum and is return sum. What is the sub-array? First understand this. Sub-array is a contiguous non-empty sequence of element within an array. What is the contiguous part? Because we all know array is a contiguous in nature. So sub-array is also is contiguous in nature, and it is maintaining the order whatever the given the array order, that the same order of the subarray. And how many non-empty subarray? N into n plus 1 by 2, if where n is the length of the given array, that many number of sub non-empty subarray you can find. But you note that empty array is also a subarray. Empty array is also array, but in this question not given. Given in this non-empty sequence. So we need to find only non-empty subarray of the whole array. So what is the subarray? A part of the array which is contiguous in nature. So I can debug this problem. You read these examples first, second, third. I using choosing the third example. Here you can understand what is the subarray of this whole array. How many subarray you can form? 15, because n into n plus 1 by 2. So n is the 5. So n into n plus 1 by 2, 15 subarray you can form this whole array. And non-empty subarray you can get 15. If you adding one empty subarray, then total subarray you can form is 16. But in this question not given empty subarray, so we can take only non-empty subarray. You can see that 5 is subarray, 5 4 subarray, 5 4 minus 1 subarray, 5 4 minus 1 7 is subarray, 5 4 minus 1 7 8 is subarray. And then starting from 4, 4 4 minus 1, 4 minus 1 7, 4 minus 1 7 8. Then starting from minus 1 minus 1 7 minus 1 7 8. Then starting from 7 7 7 8, then 8. Then this is the whole subarray, 15 subarray you can write here. And what is the sum of this? 15. What is the sum? 5 4 9. Add up whole subarray sum. Where get you maximum sum? You can see here I get maximum sum is 23. So you need to understand what is the maximum subarray. What is the maximum subarray? Maximum subarray is array whose which subarray, maximum subarray is array which produce the maximum sum among all subarray. That subarray is called maximum subarray. So this is our maximum subarray, because maximum subarray, because it is produce maximum sum. Hopefully you understand the problem. I hope you hopefully you understand the problem carefully. So we need to solve this problem. So first I solve this question in two approach. First I discuss about here brute force approach. Brute force approach. Brute force approach. And then second I discuss here one famous algorithm, Kadane's algorithm to solve this in big O of one time, in big O of n time. So this two algorithm here I use to solve this problem. Kadane's algorithm is very efficient algorithm to find subarray, maximum subarray sum. This is the very important algorithm. This is asked in many companies, multinational companies, Google and Amazon and Microsoft. So you need to monitor this algorithm. It is very effective algorithm to find the sum of all subarray. So let us first understand the brute force approach. So here I can make the file max subarray, max sum of subarray 2.cpp. Sorry, now let's include header file as include our stream using namespace std. you understand this and main. Let's first understand the brute force approach. What is I am going to tell about here brute force approach. First, in brute force approach, let's take one array A is equal to 1, 2, 3. How many non-empty array we can form this? N into n plus 1 by 2 means 3 into 3 plus 1, 3 plus 1 by 2 means comes out to be 12 by 2, 6. 6 non-empty array we can form. What is 1 is the subarray, 1 2 is the subarray, 1 2 3 is the subarray, and starting from 2, 2 is the subarray, 2 3 is the subarray, and then 3 is the subarray. So count is 3 and 3 6. Okay, what is sum this? Sum is 1. What is sum of this element? Sum of these element is 3. Sum of these element is 6, and you can again find the sum is 2, and then sum is 5, and then sum is 3, which is producing maximum sum 6. This is the producing maximum sum. So what is the maximum subarray? 1 2 3, which is producing the maximum sum. So we need to return this 6. So again sorry, here comes out to be 1 2 3, and sum is comes out to be 6, which is the maximum sum. So we need to return this maximum 6. So what is new concept I am using in the brute force approach? I iterating from first index of the array, 0th index, where I my pointing I and second loop pointing j at 0th index, and we fix ith index of 0th index I of the for loop at 0th index of array till j is not equal to the size of array. So what is you using in this? If till j not equal to n size of array till I is fixed at index of the array. And if j is equal to n size of the array, at that time I is equal to I plus 1 and j is equal to I, means when whatever place I start, at that place j must be start, and I is equal to I plus 1. Increment the I when j is equal to size of array, and when j is not equal to size of array, j iterating to whole array, and my I is fixed. So there's concept I am using here. So let us say we initialize the array int arr equal to, let's take one array. I can choosing the array of this problem given in this problem minus 2 3 4 till 4, and put in this question of now. Here I initialize int size equal to size of arr. You can get here size of the array, size of arr 0, and then next I am calling about subarray sum arr comma size. Okay, next copy paste, control C, int, control V, int star arr, int size. I can take here return type because we need to return maximum, and here I write star arr. You can also write this star arr of this. whole thing right, but I preferred this, right? Star AR. So you might write this. I write this. Okay. So here I initialize my maximum, which we need to return zero. Sorry, one condition. So I not tell about. Here I initialize sum as zero. Initially, sum is my zero. Two variable I taking. Sorry, two variable taking. Sum is zero, and one is maximum. Maximum which is point to be zero. And if at whenever max sum, whenever our sum is greater than max sum, at that condition max sum reinitialize with our value of sum. This is also using here. We can iterate the all subarray starting from 1, then all subarray starting from 2, then all subarray starting from 3, and we can find all subarray sum starting from 1, then reinitialize the sum as 0. This concept I am using here. For int I is equal to 0, and I go till the size of array, and I plus plus, and for int j is equal to I, where whatever position j is start, where I start, and I is j is go to till less than n, and j plus plus. And again here I am using sum is equal to sum plus arr of j. Okay, and if our sum is greater than max sum, at that point we need to reinitialize our max sum is equal to sum. Okay, sorry guys, here size I written, but I am using n, so we can write n. Okay, sum as reinitialize sum also, and sum is equal to 0. Now hopefully you get. Now here I return this, return return max sum. So here I can return max sum, hopefully probably get the answer. But here one catch, wrong this in this step, which is things need to be included in this sum to be 0. Whenever starting from the subarray sum, first we adding the all subarray starting from 1. Okay, when I is equal to 0, and adding all subarray starting from 1 to 3, means 1 1 2 1 2 3 6. So you can adding 1 2 3 1 2 3 then 6, then starting from 2 means you can reinitialize the sum as 0, because 2 sum is 2, then again adding 2 3. So here you adding, in adding sum, if your sum is not reinitialized with 0, then you can added 6 with 2, which is wrong. So whenever enter the loop incremented by the I value, then reinitialize our sum as 0. So here I reinitialize the sum as 0, and sum is this sum plus arr of j, and sum whenever greater than max sum, and return here sum. So there this is, and here I print the whatever output comes out to be this code, cout, and this. Let's run this code, see what is the output comes here. What is the output? 6. Yeah, you can see that output of this array is longest subarray sum is 4 minus 1 2 1, which output is comes to 6. So this is the maximum subarray which give the output is 6. So this is the concept over here. Now I can discuss about the time complexity of this code. So let's discuss the time complexity of this code. You can see that when I is equal to 0, where j go, j start from 0. When I is 0, j is starting from 0. At go till n, means go to n, j 0 to n, means this entire thing run how many times? This entire thing enter the inner the for loop runs the n minus 1 times, because when j is equal to n, then this loop get terminated because condition is false, n is not less than n. So at this, when I is equal to n 1, then j go from 1 to n minus 1, and when I is equal to 2, then j go from 2 to n minus 2, and till last when j is equal to, when I is equal to n, sorry, n minus 1, because when I is equal to n, then this loop not run because n is not less than n. So j, I go from 0 to n minus 1. Whenever I is n, j is not n, because n less than I, n is not less than n, so j is not equal to n. J go from n minus 1 to I is 2, n minus 2, I is 1, n minus 1. When I is n minus 1, then j what is n minus of n minus 1, which is equal to 1. Means when I is equal to n minus 1, at that time this is run 1 times. You can understand this. If I is equal to n minus 2, so this is runs 2 times. So you can see the pattern: 1 plus 2 plus 3 plus 4 plus 5 until last n. So we'll add up with this all things, comes out to be n into n plus 1 by 2, which is equal to n square plus n by 2. If in neglecting the constant of this, we get upper bound of this code complexity is big O of n square. What is get big O of n square? And what is the auxiliary space here I using? Auxiliary space or extra space I using here big O of 1. Hopefully you understood the complexity of this code and auxiliary space. So this is the concept of brute force approach. What is the approach here I using is brute force approach. This is the brute force approach here I used. Brute force approach. Brute force approach. Let's understand the optimal approach. We can using Kadane's algorithm to solve this in big O of n time complexity, because we need to minimize big O of n square. So we using Kadane's algorithm. How did the Kadane's algorithm tells? Here I using the sum. Here I using the sum. Okay. So Kadane's algorithm based on this: if sum is greater than or equal than 0, at that times you need to sum is equal to sum plus ARR of I. Means you can add the array, and if sum is less than 0, at that point sum is pointing to ARR of I. Sum is pointing to ARR of I. So this is the Kadane's algorithm tells. And whatever the code written here, if maximum is greater than this is all things same, not change. Kadane's algorithm based on this finding the maximum of the maximum subarray. It is used to find the maximum subarray sum. So let's start the code. Int max sum is equal to a of 0, and int sum is equal to a of 0. Let's change the name of this. Sorry, a is already written. Next, here I can use the concept for loop running for int I is equal to 0 till I less than a dot size of the array, and I plus plus, and here if sum is greater than equal than 0. At that point you need to sum is equal to sum plus a of I, else so here I initialize max sum is a of 0 and sum a of 0. So we add this, else what we can do, sum is equal to a of I, and here I can use if my max sum is less than our sum. At that point we can reinitialize our max sum is equal to sum, and after that we can return our max. Okay, so let's run this code. Hopefully pass the test cases. Yeah, comes out to error. What is the error? Second, here I can using 0, sorry guys, and then again the sum. Semicolon missing. Let's run this code. What is the error, guys? I less than a dot size. Sorry, sir. Here I mistake this a dot size, and I can run this code. Again mistake, semicolon. Let's see the what is the mistake here, and next no mistake here. So run this code. Missing the test case, sorry. Here I initialize with 0. We need to go from I is equal to 1 because a0 already taken. Yeah, accepted this. Now we can run this, submit this code. I can see the pass or not time complexity cases. Yeah, pass this cases. So you understand this complexity of this code. Complexity of this code is big of complexity. This is big of n. Upper bound this comes out to be big of n. And auxiliary space is big of 1. So this is the whole code of Kadane's algorithm to find the maximum sum of the subarray. So hopefully you understand. Thank you and bye bye.